These ones, we're checking it in y is greater than x minus 3. So remember, this is x and this is y. So if it's y is greater than x minus 3, let's plug them in. So plug in 2 for y, 1 for x. What's 1 minus 3? -2, yep. So solution or not a solution? Is 2 bigger than -2? Yes, so this one's a solution. All right, for this one, so you have -7 is greater than -3 minus 3. What's -3 minus 3? -6. Is -7 greater than -6? No, so this one's not a solution. And then plug in 0, 0. 0 is greater than 0 minus 3. What's 0 minus 3? -3. Is 0 greater than -3? Yes, so this one's a solution. Okay, and then just solving a basic inequality. So what would I do first to solve that? Yeah, -1. -2x is less than 4. And then what? Yeah, divide by -2. And do you remember what we have to do? Yeah, flip the sign. So remember, anytime you multiply or divide by negative, you have to flip the sign. All right, so we are doing linear inequalities now. So we're kind of combining like the inequality symbols, these ones that we've learned, but throwing x and y in there. So like this one up here, y is greater than x minus 3. So your objective is students will be able to graph linear inequalities into variables.
So realistically, when exactly would we use this kind of math in real life? No, this is like a genuine question.
So a lot of like anything with like lines and stuff like this you use in like finance. So like if you have a company and you're looking at like costs and budgets and stuff like that, use this a lot.
Good to know.
All right. So for these, the idea is that, well, first, let me ask a question. Which one has more solutions, an equation or an inequality? An inequality, yep. So if you look at this, if I have just x equals 2, that means my only answer is 2, right? It has to equal 2. If it's x is greater than 2, then anything bigger than 2 is going to be a solution. So it has way more. So on a line, typically, when you have an equal sign, any point that falls on that line is going to be a solution, and that's it. Okay, so it has to be on the line to be a solution. As soon as you change that over to be an inequality, then the solutions extend to now one entire half of the graph. So the line is going to kind of separate your graph into like two parts, and then all of your solutions are going to be located on one side of the line or the other, right? And then if it's a solid line, it's going to be also on the line. But sometimes we'll have a dashed line, which is like an open dot, like not equal to, and then it won't be on the line. It'll only be in the shaded part, okay? So we are going to just start by deciding if things are solutions or not. So we have 0, -2 is me right here. So that is not in the shaded part. So would it be a solution or not a solution? Okay, 2, 8. Right here. So what would that be? And what we mean by solution versus not solution is that if we had the inequality for this, like the y is greater than x minus 3 in the warm up, if we were to plug in the x and y, it would work. Okay. -3, -6. Go to that one. Nope. Okay, -9, 0. Yeah, that would be a solution. And then 1, 3. So this one lands exactly on the line. So the way that you're going to be able to tell is if you have a solid line or a dashed line. A solid line is going to be like the filled in dots that are equal to, and then the solid lines are going to be like the open dots where it's not equal to. So since this is a dashed line and it falls on the line, then it's not a solution.
Is a solid line a solution or not a solution?
Solid line is the solution, yeah. All right, you guys going to do this one, and it's kind of hard to see which one's shaded, so I'll shade it in. It's this top side that's shaded. Okay, so we have 4, -4. It's right here, so what's that going to be? Yes or no? Nope. Okay, 0, 2. Yes. 2, -2. 5, -4.5. -2, 3. So that one lands on a solid line, so that one would be a solution. Okay, we good? Okay, so now to graph these. There are two methods. The method one is the way that the book is going to teach you, and that is by using a test point. So with this method, you can graph it however you want to graph it. So if it's in y = mx + b form, that's perfect. If it's in standard form, you can use the intercepts. If it's in point slope form, you can use the point and the slope. However it comes, you can graph it like that, okay? But then what you have to do is you have to pick a point, any point that you have. Usually we use 0, 0 just because it's the easiest, and 0, 0 is on one side of the line or the other most of the time. But you'll plug it in. So let's say my line is like this, okay? Like right here. So if I plug in 0, 0, and it turns out that it is a solution, then that means that that whole side has all the solutions because it's one side or the other. If it turns out that 0, 0 is not a solution, then the other side has to be the one with all the solutions, okay? So that's one way to do it. This is the way that we're going to do it. So this is like the shortcut way for the shading. The only trade-off, though, is if you're going to do the method that you don't have to plug in a point and test it and all that, then that means that everything that you graph has to be in y equals mx plus b form. So if it's not, you have to convert it over to y equals mx plus b form. So if that's not your strong suit, then I would look at this method, which I'll go through with you guys on one of the examples. Actually, I'll probably just do it with you right now so that we can do it once and then call it. So here is, let's go to example number let's go to the problem 4 and the got it real quick. Just skip back to these ones because these ones are in standard form. So these are the ones where you would have the distinction between the two methods. If they're in y equals mx plus b already, then the second one's the way to go, okay? So typically if we were going to graph like, let's do, I'm going to do method 1 on both of these, okay? So I'm going to do the got it first. Or actually, I'm going to do method 1 and then method 2 so you can see like where the work is the trade-off. So for this one, if I wanted to use method 1, the way the book would teach it. So you can graph it however you want to. Typically in standard form, we graph using the intercepts, okay? And you could just use an equal sign for the intercepts because it's just a point on the line. So here, if I'm trying to find the x-intercept, I cover up the y, right? That's 0. So I get negative x equals 1. So what does x equal? Negative 1, yep. So you're going to put your dot at negative 1 on the x-axis. And then if I cover up the x, then I just get y equals 1. So you're going to put your dot at 1 on the y-axis. And then you can just connect the dots. So as far as what type of line to use, if you have the line underneath that symbol, like the equal to line, then you're going to use a solid line to connect them. If you don't have that line, you're going to use the dashed line. Okay, so this one would be a solid line. And then we are going to have to use a test point. Yeah.
So how did you get x equals negative 1?
Because you divide by the negative in front of the x.
Oh.
Okay. So then to figure out what side of the line to shade, we're going to just pick a point and test it. So usually 0, 0 is the one we pick because it's, unless the line goes through 0, 0, then you pick a different one. But if you can, just pick that one. So plug in 0 for the x and 0 for the y. So 0 minus 0 is greater than or equal to 1. 0 is greater than or equal to 1. Is that a solution or not a solution? What? Yes or no? Not a solution, right? So since 0, 0 is not a solution, that means that that whole side of the line has all the not solutions, okay? So then that means that we would shade what side line? What side's going to have the solutions then?
The left side?
The other side, yep. So this side of the line would get shaded. Okay, so that's the first method. That's the way the book will teach you, is to use a test point to figure out the shading. Now, there is a cheat for the shading that you can do where you don't have to do a test point. And that's going to be method 2. What we're going to do on this one. For this method, you don't get to graph using the intercepts, but then you don't have to do this either. So what you're going to have to do is you have to turn it into y equals mx plus b form. So what would I do first to get the y by itself? You have to subtract 2x. So negative y is greater than negative 2x minus 1. And then what? Yep, divided by negative, which means I have to what? Flip the sign. So you get y is less than positive 2x plus 1. So then what's my y-intercept? 1. What's my slope? Yep, 2 over 1, so we go up 2 over 1. Okay, save that. And then you're going to look at your symbol right here. This is like the cheat, so you don't have to plug in a point. So that symbol right there, does it have the line underneath it? No, so that means it's going to be solid or dashed? Dashed. Just going to make like your dashed line. And then the trick for shading is if it is a greater than sign, you shade above the line. If it's a less than sign, you shade below the line. So which one would you shade here, above or below? So below the line is going to be down here. So that's side of line. So depending on the methods, you're kind of trading off one work for the other. So you either are going to put your effort into using a test point and plugging it in for the shading, or you're going to put your effort into putting it into y equals mx plus b form. It's really up to you and where you are strong at, okay? If it's already in y equals mx plus b form, though, then this one's the way to go because you don't have to use a test point. You won't really have to do a whole lot of work at all, okay? Any questions so far? So that's going to only come up really the difference between the two if you have a problem that's like in standard form, okay? So now let's go back to the beginning. Okay, so if we look at this first one, if y is greater than x minus 2, it's already in y equals mx plus b form. So what's my y-intercept? Huh? Yep, negative 2. And my slope? 1. Okay. And then we're going to look at our symbol right here. Is that going to be a solid line or a dashed line? Dashed. So I'm just going to keep it dotted like that. And then, because it's minus 2. And then it's a greater than symbol, so would I shade above or below? Above. So that's me up here. Okay. Go ahead and try the next one. below. Yeah. Okay, so for this one, what's my y-intercept? 1. My slope? 1/2. So up 1/2. Okay, and then if we look at the symbol, is it going to be dashed or solid? Dashed. And then shaded above or below? Okay, so down here. Okay. Good? Cool. All right, next one is x is greater than or equal to -1. Do you remember what kind of line that is? It's a vertical line. Because x, no matter what, is -1. So at -1, we're going to do a dashed or solid line? Solid. And then shaded above or below? And so above on a vertical line is going to be to the right because it's like the bigger numbers. And go ahead and do the got it. Okay, so what kind of line is it if it's just y is greater than 2? Yep, horizontal line. And is it going to be solid or dashed? And shaded above or below? Good? Okay, and then you have the other option for doing this. If it's not in y equals mx plus b form, then we went over how to do that, okay? So now I want you guys to go through and try to figure out that one. Okay, do we know which one we think it is? Which one? Yes, it is. So the correct answer is D. People typically always pick which one do you think? A, yes. So the idea here is that these are not in y equals mx plus b form. So we know that like the symbol should be this, right? Because it's dashed and shaded above. However, see the negative in front of the y? So whenever you're solving this for y equals mx plus b form, you're going to have to divide by that negative, which is going to flip the sign. So in y equals mx plus b form, it's going to be y, it's greater than like that, which makes it the right one. Got it? Yeah? Okay. So like this one's going to be y is greater than or equal to, y is less than or equal to, and y is less than. When it gets in that form. Okay? All right. Let me put your lesson check up. All right, so number one, you're going to graph All right. So for this one, you should have started at 3, and then down 2 over 1. And then you should have a solid line. And then it should have been shaded below, so on this side. Okay, and then the other one, there's going to be a vertical line at -1 that's dashed. And then it's less than, so shaded below, so this side.